Chapter 5.4, Half-Angle Identities. This is the last section we'll be doing in Chapter 5. And we are going to be using these half-angle identities to do the same thing we've been doing before, and that is to find exact values using these identities, and we're also going to use these identities to verify. I am making two videos. One is simply on using these identities, and video number 2 will be on verifying. You do need to watch both these videos before the next class. One other thing that we have in this chapter is the derivation of the double angle identities. I'm not going to derive those for you, but if you'd like to see the derivations are on page 282 to 283 of your textbook. Now let's see these identities. Here are your half-angle identities for sine, cosine, and tangent. Note that sine and cosine each have one half-angle identity associated with them, whereas tangent has 3. When you're using tangent, you get to choose which one of these identities you'd like to use, and that is based on the information that is given to you. One other thing that you do need to notice, and that is each one of these has a plus or minus in front of it. You will either use the positive or the negative version, depending on what quadrant the angle that you're trying to find the trig function for is located. And I'll show you how to do that as we work through a few examples. Here is our first example. We're going to use a half-angle identity to find sine of 22.5 degrees. 22.5 is not one of our principal angles on the unit circle, but I am going to find one on the unit circle that I can use an exact value of. I went ahead and copied what the textbook gave us. However, they skipped some steps, so I will show you each and every step. The first thing you need to do is look at the angle that's given to you, this 22.5, and say 22.5 is half of what angle? Or you can look at it another way, 22.5 times 2 is equal to what? Well, that's equal to 45 degrees. So I am simply now going to substitute 45 divided by 2 for the 22.5. I'm also going to now use the positive version of the half-angle identity for sine because 22.5 is located in quadrant 1 and sine is positive in quadrant 1. Note how we set this up. I write sine of 22.5 as sine of 45 degrees divided by 2. 45 is the x from my equation, not the 22.5, but the 45 degrees. So I rewrite this as square root of 1 minus cosine of 45 degrees divided by 2. I substitute the value of cosine of 45 degrees, which is square root of 2 over 2, into my equation for my next step. And that's what they've done here, right here in this step. However, it's a little confusing to see how they got from this step to this step. So I will show you what they did. First thing you would do is you would substitute a fancy form of 1 for 1 so you can combine the fractions in the numerator of this complex fraction. So I simply wrote 2 over 2 for that 1. And then I'm going to substitute a fancy form of 2. I'm going to write that as 4 over 2. The reason I did that is I want to get the same thing in each one of these denominators, because they will cancel out if we do a keep flip change. What happens here, if I combine this into one fraction up on top, and write this as 4 over 2 on the bottom, if I did the keep flip change, remember these two denominators would simply cancel out, and I now have 2 minus the square root of 2 all over 4. And of course the square root of that. And your final step is to take the square root of that denominator, because we do want to rationalize this denominator. And fortunately, 4 is a perfect square, so I can just write 2 in my denominator. And my numerator is 2 minus the square root of 2. And I do not need to rationalize my denominator. So my final answer now is simply what they show. Square root of 2 minus square root of 2, all divided by 2. You can leave that as your answer. Let's look at another example where we're using radians. Okay, now I have used a half angle identity to find the exact value of tangent of pi over 8. I need to know what pi over 8 is equal to, well, what did I do with that 22.5? I multiplied it by 2, didn't I? So that's exactly what I'm going to do to this pi over 8. I am going to multiply it by 2 to see if I can find an angle, principal angle on my unit circle to substitute. See, we have, that's 2 pi over 8, which is equal to pi over 4. Okay, that tells me right there that pi tangent of pi over 8 is the same thing as tangent of pi over 4 divided by 2. That's just the opposite of what I did here. A little confusing. If you don't understand it, ask your questions in class. Just note that now I'm going to use this pi over 4 as my x, and I'm going to choose one of my half angle identities for tangent. But before I choose that, I am actually, I could use any of them actually, so I'm just going to choose one that I think is pretty easy to use. And the one I've chosen to use is 1 minus cosine of x divided by sine of x. And remember, my x is pi over 4. So wherever I see an x, I'm going to put a pi over 4. So I'm simply going to write 1 minus cosine of pi over 4 divided by sine of pi over 4. We all know that cosine and sine of pi over 4 is square root of 2 over 2. I'm simply going to substitute square root of 2 over 2 for both sine and cosine. I'm going to do my algebra and simplify that complex fraction. Here is my work. What I did here is I took the 1 minus square root of 2 over 2, wrote a fancy form of 1, which is 2 over 2, to write this into one fraction right here. And then I can cancel out the denominators to get 2 minus the square root of 2 divided by the square root of 2. I'm sorry I'm not working down in the column, but unfortunately the software I'm using does not allow me to do that. I ran out of screen room. Now I'm going to rationalize that denominator by multiplying by the square root of 2 over the square root of 2. I end up with 2 times the square root of 2 minus 2 all over 2 when I do my multiplication. One last simplification, and that is because 2 goes into both items in the numerator, or both terms in the numerator as well as the denominator. Those will cancel out, and I can simply write my final answer as square root of 2 minus 1. Or the better way to look at it is to write it as negative 1 plus the square root of 2. However, I will accept either answer. Here's one for you to try. Remember to find the angle for x that you need to use. You take the fraction you currently have here, this 11 pi over 12, you multiply it by 2 to see if you can find an angle that is on our unit circle. So we'll talk about that when you get to class. Okay, now we're actually given different information. In this one, we're given cosine of x, which is negative 5 over 13. We're told that sine x is less than 0, and we actually need to find cosine of x. So what I need to do here first is decide if I'm going to find cosine of x over 2. But the first thing I need to do is determine if I'm going to use a positive or negative version of my half-angle identity. Let's look at this. If cosine of x is negative, and sine of x is less than 0, which means sine is also negative, then that tells me that my angle x is in quadrant 3. Now remember, quadrant 3 angles are somewhere between 180 degrees and 270 degrees. If I divide those by 2, that tells me that x over 2 is somewhere between 90 degrees and 135 degrees. It means x over 2 is in quadrant 2. That's an arrow, by the way. Okay. And cosine is negative in quadrant 2, so I need to use the negative version of the half-angle identity. Because I'm trying to find cosine, I'm going to use the half-angle identity of cosine. And here's my work. To start with, I wrote the negative version of cosine. Because I'm given cosine of x already, I just take this 5 over 13 and substitute it in where I see a cosine of x. Negative 5 over 13. Now I'm going to do some algebra to simplify that. Okay, I'll walk you through my steps. I changed the 1 to a fancy form of 1 of 13 over 13, so I would have the same denominator and can combine it into a single fraction. 13 minus 5 is 8, and it would be over 13. The 26 over 13 came from this 2. I simply wrote a fancy form of 2, because 26 divided by 13 is 2. And I chose to write it like that, so I could use the trick that if you have a complex fraction, if they both have the same denominator, they will cancel out. Because if you use keep flip change, they would cancel out. I then have negative square root of 8 over 26. I did some simplification till I got down to negative 2 of the square root of 13. I rationalized that denominator, and my final answer now is negative 2 times the square root of 13 all over 13. If you want to check your answer, we'll check our answers when we get in class. Because I want to go ahead and stop right now, and the next video will be on verifications. Please watch that as well.